Hey everyone, this video has been requested and it took me a little while to get around to it. Sorry about that, but we're going to work our way through this proof. So we're going to prove the following statement. We're saying that for all values of m greater than 0, there exists an n greater than 0 where n squared is less than m times 2n cubed minus 3n minus 1. So we did some of these problems previously, but this would have been the first one where we had multiple terms. I think it's the first one that has multiple terms. We may have done one other. I can't remember now. We certainly see it on the assignment. So let's walk our way through this to see if we can understand what's going on. So I'm just going to start by rewriting this statement. I'm going to just pick a little bit of a darker color, just why not? And we're going to start right here. This is just going to be my scrap work while I try to determine what that value of n actually should be. Okay, so the first thing I'm going to do is when I have this really big side over here is I'm going to factor out that largest n term. So I'm going to factor out an n cubed, and we're going to get n squared m, take that n cubed out, and that will leave us with 2 minus 3 over n squared minus 1 over n cubed. Now, we've said before, there we go. We've said before that we don't love like all the negatives and stuff in here. So I'm going to actually factor a negative out of these two terms so that I can remove this one. So I'm going to go ahead and factor a negative out. So again, I'm just going to rewrite this. So I haven't actually done any type of arithmetic yet. I haven't done any kind of manipulations of the two formulas here, or the statement rather. All I did was rewrite it in a way that looked nicer for my brain. So that's what I'm doing right here. All right. So we'll take this. This is what we're working with right now after we have done all of that factoring. So now what we're going to try and do is we want to try and, as we've said before, turn this whole term over here. Turn this whole term over here into a number that's easier for us to work with. And there's more than one right answer for these proofs. We have to remind ourselves that when we're trying to do a there exists, it's absolutely possible to find more than one correct answer, right? Especially in the reals. So just because I might come up with an answer of, let's pretend, not what I'm going to get to, but 4, and somebody else comes up with 6, if I'm saying n is greater than 4 and someone else says n is greater than 6, if it's true for this one, it will also be true for this one, right? Because if n needs to be greater than 4 for it to be true, and somebody else wants to put an even tighter bound on it, saying it can't be 4 or 5, it has to be 6. 6 is also greater than 4, so that's okay. Like that, there's nothing wrong with that. So it's just something to keep in mind when you're reviewing this question. If you came up with a different n value, that doesn't make it wrong as long as you can prove the statement, then you're good. So a reminder here that I like to try to get this to a place where it's equal to a half. So in order to do that, I'm going to need to find a way to turn this right here into 1.5 so that I can say 2 minus 1.5 at the end, right? That's really what we're trying to get to. So if we're going to try and do that, given that there's a 3 on top of this one, I'm going to find a way to get this one strictly less than 1, this one strictly less than a half, and then I'll be able to replace that with 1.5. And then I'll be able to do 2 minus 1.5, and I will get my half that I'm looking for. So let's start by thinking about values of n where this might help us. If we take n equals 1, and we do 3 over n squared, we're going to get 3 over 1, which is not less than 1. So that didn't work. Let's look at the next value. N equals 2, 3 over 4. Well, that is less than 1, but does it work for the other side? Trying to get it less than a half. So let's just check. 1 over n cubed needs to be 1 over 8. Well, that's less than a half. So actually that value works really well for us. We've now found a value for n where we can take this term and say that we're going to be less than, that our original value is less than 1.5. So what we're going to be able to say in the future shortly is that 2 minus 3 over n squared plus 1 over n cubed, like this, is strictly less than 2 minus 1 plus a half. This is what we're trying to say, and we can say that as long as we're going to make sure that our value of n is greater than 2. That's what we're working up toward right now. We're going to need this when we actually do our proof on the other side. Okay, so let's keep going. So now that we have found that value, and we don't want to lose it, we're like, yep, that's important. Let's remember that. Let's keep working through this problem. So now we can replace those two things in there such that if we can find the other bound of the other maximum bound of n, that if we can show that this will end up becoming a half, if we can show that this, we've already shown that this is less than the original question, the original statement, 2, 3 over n squared plus 1 over n cubed. So for that value of n, we've already shown this to be true. We've shown, I'll be even more specific, we've shown this part to be true for that value of n in our scrap work, but now we have to work our way through this side of it as well to make sure that we are picking an n that will uphold that bound as well. So let's keep doing that. We have n squared less than m over n cubed like this. What can we do here? We can, I don't know, we can multiply both sides by 2 so that we end up with 2n squared over m n cubed. We can divide both sides by m so that we end up with this. Just cross those out. And then we could divide both sides by n squared so that we end up with 2 over m being less than n. So now we have found our other band. Fantastic. Let's just rewrite our statement here that we're trying to prove just so we don't forget it. There exists an n greater than 0 where n squared is less than m 2n cubed minus 3n minus 1. All right. So let's prove it. Let n be a maximum between those two terms we found in our scrap work, plus 1. We do that so that we can then say, observe in 1 that n is greater than this max without that plus 1. Okay, so now that we have that information, let's rearrange our formula as we did before, get it in a state that we can work with. So let's factor n, n cubed out of the right-hand side of our statement. We're going to do n squared is less than m n cubed 2 minus 3 over n squared minus 1 over n cubed. And then the next thing we'll do is we'll also factor a negative out from the back there of that right-hand side. So we'll do n squared less than m n cubed 2 minus, factor this term out over here, minus 1 over n cubed. Okay, so 5. From 2, we know that n needs to be greater than 2. So armed with that information, it follows that 3 over n squared is definitely going to be less than 1, because that'll be 3 over 4. And 1 over n cubed is going to be definitely less than a half. So knowing that, if we substitute those two values in, we're basically able to then say that m times n cubed 2 minus 1 minus a half will all definitely be less than our original statement. M n cubed 2 minus 3 over n squared minus 1 over n cubed, like so. Okay, so we know that that's going to be the case. So now let me just label these for a second as this part of the statement as an A, our new intermediate that we just made as B, and our original ending statement as C. So what we can see is we just proved that B is less than C. That's what we just proved by knowing that n was greater than 2. So the next thing we need to do, next we prove that A is less than B. And once we do that, if A is less than B and B is less than C, it follows that A will be less than C. So let's do exactly that. We've already done this one. Yay. All right, let's look at how we figure out how to do the A less than B one. So right now, we also can say that we're going to go to 6 here. From 2, we also know that n is, what was our original, let n, 2m. N is going to be greater than 2m, right? So we know that that's true as well. So knowing that information, we're going to try and make that look like this term right here. That's what we want to try to get back to. So I'm just going to copy it just as a little reminder for myself while I'm working through this. Because if we can, whoops, if we can get back to that term over there, this term came directly to us from, if you don't remember, if we come back up here, from this 1/2 situation, right? When we took that half out, we ended up with n squared less than m times n cubed over 2. So when we mushed all that around, we ended up with this. And if we can show that this, that I've currently got highlighted, if we can show that this can be transformed into this, we will be able to have proven what we're trying to prove here. So let's take that n over 2m. And now, armed with the fact that some kind of manipulation is going to need to happen here to make it look like this, let's see what needs to change. Well, I can see that my m is definitely needs to be not in a denominator. So let's do like a 6a multiply by m. So we multiply both sides by m, we're going to end up with mn over, or is greater than 2. Okay. I don't know why I put the 2 up there, like as if that's how math works. Because it's not. I multiplied. Oh, yes. Sorry, I don't know what's wrong with me. We know that that's correct. Multiply both sides by m. Wow, I don't know what's happening to my brain today. That's okay. I can get my brain back to where it needs to be, I think. So then we can divide both sides by 2. Okay, 6b divide by 2. So we'll end up with mn over 2 is greater than 1. And the last thing that we need to do here, 6c, is multiply by n squared. And we'll have mn squared over 2 is going to be greater than n squared. And now we can stop because here we have this piece right here. And a reminder that this is basically just our b rewritten. This b, I'll come back here and just show it. mn cubed 2 minus 1 and 1/2, which would be mn cubed 1/2, which is mn cubed over 2 less than our statement there. So we already had this term that we got. We just didn't actually expand it out as B. But this is our B, and this was our A. So now we can say as 7, as seen in 6, n squared is less than mn cubed over 2, which was less than whatever our original statement was, m over 2n cubed minus 3n minus 1. And then we're done because we did it. We proved it. We've got one statement here being less than this statement here. And we have now proven that to be true. So hopefully this shed some light for people on how this whole process works. And as always, if you have any questions, please don't hesitate to reach out. Thanks, everyone, and have a great day.